Hello, advanced geometry students. Mr. Donaldson here, talking with you today about surface area. So this is section 8.7 from your text. So feel free to read that section to get more clarification. So the first concept here is just kind of the big idea of surface area and the steps to finding it. So we have the steps here. But before we get into that, I suppose like surface areas, imagine you have a geometric solid and you want to know the sum of the areas of all the surfaces of that solid. Like for instance, if you have a cardboard box, the surface area would just be the area of all 6 faces of that cardboard box added together. So the process for finding surface area is 1, draw and label each face of the solid as if you had cut the solid apart along its edges and laid it flat. And be sure you label the dimensions. You'll notice I've done that here in this first example. I've got all 6 surfaces of that box drawn and labeled. Next, calculate the area of each face. In that example below, I have all the areas calculated. And then finally, the last step is to add up all the areas of the faces, and that will give you your total surface area. And I have that for this example right here. So by adding up all 6 of those surfaces, you got the 12, the 12, the 32, the 32, the 24, the 24. All of those surfaces together have a sum of 136 square feet. So that will be the surface area of that rectangular prism, or the box there at the left. Okay, so a little bit of vocabulary regarding solids. I know we discussed some of this back in chapter 1, but this is a little recap and maybe a reminder here. So first of all, this first solid here is a prism. This is a hexagonal prism because it has hexagonal bases. Also, this is what's referred to as a right prism because those lateral edges, like for instance, this is a lateral edge, is perpendicular to the base. We're going to deal with right prisms. There's also called oblique prisms, which will kind of look like this. Let me see if I can draw one here. It would be kind of a prism that's maybe slanted a little bit. That will be an oblique prism because the lateral edges, this guy right here, is not perpendicular to the base. Anyway, we're going to deal with right prisms. So, the 2 parallel congruent faces are called our bases. All of these other faces, these other, in this case, 6 rectangular faces that are not the bases, are called lateral faces. All right, next is a pyramid. Now, a pyramid also has a base. In the case of this pyramid, it has 1 base. All right, a prism has 2. And in the case of a pyramid, those lateral faces are no longer rectangles. In this case, there are 4 lateral faces, and they're all triangles. But in terms of breaking down the parts of a pyramid that will be helpful, is you have, this is what's referred to as the slant height. And the slant height goes from the vertex of the pyramid perpendicular to one of those base edges, right? This is called the slant height. And the variable that we use to represent slant height is a cursive L. All right, and in this, here in the middle, the actual perpendicular distance from the vertex down to the actual base itself is the height. So, what is the difference between the lateral faces and the bases? So, if you're watching this at home, that means you weren't in class today, which means you don't really have a partner to discuss this with. So, why don't you pause the video, take a moment, and think about what's the difference between lateral faces and bases. And I just kind of mentioned some of that in my discussion. All right, welcome back. So, what you should have noticed regarding the differences between the two is that the bases of a prism, there are 2 congruent parallel faces, all right? And also, all of those lateral faces are rectangles. And in the pyramid, there's 1 base, all right? And then there are, however many sides that base has, there's that many lateral faces. In that case, they'll all be triangles. I have all of this stuff written out if you look at the filled-in version of the notes, which may be helpful so you can see it in writing. What type of polygon is the lateral face of a prism? Lateral faces of a prism, and I guess I should say a right prism, because if we're dealing with an oblique prism, it would be parallelograms. But if they're right prisms, it's a rectangle. and of a pyramid, triangles. What is the difference between the height and the slant height of a pyramid? Again, take a moment and think about this, and then what I'll have you do is just go and look at the filled-in version of the notes to see what I have written. And then the last thing on this page here is why do we need the slant height for the surface area? And this is really important to bring up because when you take that pyramid apart, for instance, that pyramid above is made up of one square and 4 triangles, and you draw all of those faces two-dimensionally, that slant height actually represents the height of one of those triangles. So the slant height is really important for finding surface area because the slant height is the height of a lateral face, or in the case of a pyramid, a triangle. And of course, you'll need the height to find the area of one of those triangles because the formula for every triangle is 1/2 base times height. All right, so here's just a quick example. I'm just going to do these two. There are 4 in the notes packet there. I'd like for you to do the other 2 on your own, and then you can check your answer by looking at the filled-in version of the notes on Schoology. All right, so this is a rectangular prism. All right, and so the way I do this, because it's a rectangular prism and because the left side and the right side are going to be congruent, and the front and the back are going to be congruent, and the top and the bottom are going to be congruent, the way I set up my plan of attack, rather than draw all 6 faces, is I'm going to say I've got 2, and then we'll do maybe the front and the back first. So each front and back face is 8 by 3. Plus, there's the left and the right, which are congruent. There are 2 of those rectangles, and each one has dimensions of 5 by 3. And finally, there's the top and the bottom. And the top and the bottom are congruent, so there's 2 of them that are the same, and they have dimensions of 8 by 5. Now, you all, I know this. You could do I know you could probably do this in your head, but it's really important for you to not make mistakes, and for us when you're grading your papers to show all of this work. Right now, you're showing that you conceptually understand how to find surface area, and then if you make a small arithmetic error, we can see where that problem occurred. So here, each rectangle has dimensions 8 by 3, plus each of these rectangles had dimensions 5 by 3, plus this rectangle has dimensions 8 by 5. And I'll do my math. There are 2 24 square meter areas, plus 2 15 square meter areas, plus 2 40 square meter areas. So now, for finding my surface area, I'll simply add all those together. Let's see, this would give me 48 square meters, plus 30 square meters, plus 80 square meters. And so together, the surface area of this entire thing is 158 square meters. All right, for our second example here, we've got a hexagonal prism. And so in the hexagonal prism, what we have is we have 2 octagons plus 8 rectangles. Those lateral faces are all rectangles. All right, so the formula for the area of an octagon is 1/2 times the apothem times the perimeter, plus the formula for a rectangle is base times height. So we're just going to plug in. For this octagon, the apothem is given to us to be 9.7. And the perimeter, there's 8 sides, and each side is 8 centimeters long, which gives me a perimeter of 64. Plus, when I look at my rectangle, each rectangle has a base of 8 and a height of 20. And now we're just going to crunch the numbers. So here, when I multiply all of this fun stuff together, 2 times 1/2 is 1, times 9.7 times 64 gives me 620.8 square centimeters. Plus, when I multiply this together, I get, 8 times 20 is, 160, times 8 is 1,280. And when I add all that together, I get that the surface area of this octagonal prism is 1,900.8 centimeters squared. So pretty straightforward. If you could find the area of two-dimensional objects, the surface area is not much harder. You just got to find a couple more and add them together. All right. So now we're going to get into a cylinder. If you think about a cylinder, like if you take a sheet of paper and you roll it up, you can form a cylinder pretty easily. And if you unroll that sheet of paper, what you would end up with is you'd end up with a rectangular or sheet of paper. Now, when we're dealing with a cylinder, if you were to unroll this cylinder, that bottom dimension there, this 2 pi r, where that comes from is the circumference of the cylinder. And then the height of the cylinder will be the height of that rectangle. So that will give you that lateral surface is what we call that part. This is called the lateral surface. And then each of these, of course, are called our bases. All right, so why is one dimension of the rectangle 2 pi r? Well, the reason for that is because 2 pi r represents the circumference of the circular base of that cylinder. When you were to unroll it, that circumference would be the length of that rectangle. So the lateral area, which would simply just be the area of the lateral surface, is just that rectangle, and its dimensions are 2 pi r times h. So 2 pi r h is the formula for just the lateral surface, not including the two bases of the cylinder. For the two bases, there are two circles, and each circle has an area of 2 pi, or each circle, is an area of pi r squared, but there are two of them, so you get 2 pi r squared. So the formula for the surface area of a cylinder has two components. There's the 2 pi r h plus the 2 pi r squared. And it's really important that you understand that this first part, the 2 pi r h, it represents the lateral surface. Because if we were going to give you a cylinder that didn't have a top, like a trash can or something, then you would only count for the surface area one of those bases, but you would include the lateral surface. And then this represents both bases. So depending on the context of the problem, you may need to adapt your formula. If there's only one base or something like that, you'll see examples in just a moment where we'll have to take that into consideration. So let's take a look at just a quick example here. We'll do one together, and then I have you do the other one on your own and check your work with the filled-in version of the notes. So we want to find the entire surface area. It doesn't say lateral surface area, it says the surface area. So I'm going to use the entire formula, which is 2 pi rh plus 2 pi r squared, and I'm going to plug in. So the surface area is 2 times pi, times the radius in this case is 6, times the height is 12, plus 2 times pi, times the radius is 6, squared. All right, so this first part gives me 2 times 6 is 12, times 12 is 144 pi, plus 36 times 2 is 72 pi. So the entire surface area of this cylinder is 216 pi square inches. Again, I'd like for you to try the second example and to check your work on the filled-in version of the notes. And then the last thing today is a cone. And if you were to take a cone and you were to cut it up and put it into two-dimensional surfaces like we see here, this part is referred to as the lateral surface of the cone. That curvy part is the lateral surface. The bottom, of course, is the base. Right? And then you have the slant height, just like a pyramid. It's that height from the base to the vertex. And then the radius, of course, is the radius of the circle itself. If you were to take all these little sectors and make them infinitely small and piece them together, you would get a polygon that resembles a rectangle. And the area of that rectangle will be pi r times L. Pi r comes from, of course, half of the circumference of this, because the distance from here to here was 2 pi r. But if I've taken half of those sectors and put them on the bottom and half on top, then each of those dimensions is a single pi r. And then the height of that rectangle will be L. So the lateral area for a cone will be pi r L. It's really important you memorize that that's the lateral surface. Then, of course, you have your one base.